Imagine a world beyond our own, a red planet full of mysteries. For centuries, we've looked at Mars, wondering if life could exist there. Now, thanks to amazing discoveries from NASA's Mars missions, we're closer than ever to finding out. Get ready to be amazed as we explore the latest news about Mars. From flowing liquid water on its surface to hidden reservoirs deep underground, Mars is sharing secrets that could change how we understand the universe and our place in it. Recent findings from NASA's Mars Reconnaissance Orbiter (MRO) provide compelling evidence that liquid water flows intermittently on present-day Mars. Using an imaging spectrometer, researchers detected signatures of hydrated minerals on slopes where mysterious dark streaks, known as recurring slope lineae (RSL), are observed on the Martian surface. These dark streaks ebb and flow over time, darkening and appearing to flow down steep slopes during warm seasons, then fading as temperatures drop. They typically appear in several locations when temperatures rise above -10 degrees Fahrenheit, disappearing during colder periods. John Grunsfeld, astronaut and associate administrator of NASA's Science Mission Directorate, expressed excitement about the findings, stating, "Our quest on Mars has been to follow the water in our search for life in the universe. Now we have convincing science that validates what we've long suspected. This is a significant development as it appears to confirm that water, albeit briny, is flowing today on the surface of Mars. These downhill flows, associated with liquid water, raise intriguing questions about their formation. The detection of hydrated salts on these slopes indicates that water plays a crucial role in creating these streaks. Hydrated salts lower the freezing point of liquid brine, similar to how salt melts ice on Earth, suggesting that a shallow subsurface flow could be wicking enough water to the surface to cause the observed darkening. Images produced by the High-Resolution Imaging Science Experiment, HiRISE, show dark, narrow streaks emanating from the walls of the Briny crater on Mars. These streaks, hypothesized to be formed by the flow of briny liquid water, are several hundred meters long. Lujendra Ojha of the Georgia Institute of Technology, lead author of a report published in Nature Geoscience, noted, "We found the hydrated salts only when the seasonal features were widest, suggesting that either the dark streaks themselves or a process that forms them is the source of hydration." Ojha first noticed these puzzling features in 2010 while using HiRISE images. The new study pairs HiRISE observations with mineral mapping conducted by MRO's Compact Reconnaissance Imaging Spectrometer for Mars, CRISM. Spectrometer observations showed signatures of hydrated salts at multiple RSL locations, specifically when the dark features were relatively wide. When RSL were less extensive, no hydrated salt was detected. The researchers interpret these spectral signatures as hydrated minerals called perchlorates. The hydrated salts most consistent with these signatures include a mixture of magnesium perchlorate, magnesium chlorate, and sodium perchlorate. Some perchlorates have been shown to keep liquids from freezing even in extreme cold, down to -94 degrees Fahrenheit. On Earth, naturally occurring perchlorates are found in deserts, and some can be used as rocket propellant. Perchlorates have previously been detected on Mars, with NASA's Phoenix lander and Curiosity rover both finding them in the planet's soil. Some scientists believe that the Viking missions in the 1970s may have detected signatures of these salts. However, this recent study marks the first time perchlorates in hydrated form have been identified from orbit, revealing new insights into the planet's surface processes. MRO has been examining Mars since 2006, utilizing its 6 scientific instruments to gather data. Rich Zurek, MRO project scientist at NASA's Jet Propulsion Laboratory, JPL, stated, "The ability of MRO to observe for multiple Mars years has enabled findings such as these. First identifying the puzzling seasonal streaks, and now making a significant step towards explaining their formation." For Ojha, the findings are further proof that the dark lines observed on Martian slopes indicate present-day water. When most people talk about water on Mars, they usually refer to ancient or frozen water. Now we know there's more to the story, he explained. This is the first spectral detection that supports our hypotheses about liquid water formation for RSL. The discovery contributes to a growing body of breakthroughs from NASA's Mars missions. Michael Meyer, lead scientist for NASA's Mars Exploration Program, emphasize the importance of these findings. It took multiple spacecraft over several years to solve this mystery, and now we know there is liquid water on the surface of this cold desert planet. The more we study Mars, the more we learn how life could be supported and where resources exist to sustain life in the future. In a parallel development, scientists have also identified a reservoir of liquid water deep within Mars's rocky outer crust. This revelation stems from data analysis from NASA's InSight lander, which has been operational since it landed on Mars in 2018. Equipped with a seismometer, InSight recorded vibrations, Marsquakes, from deep inside the planet over a 4-year period. By analyzing these quakes and the movement of the planet, researchers uncovered seismic signals indicative of liquid water. The InSight mission aimed to investigate the evolution of rocky planets, including Earth and Mars. While frozen water exists at the Martian poles and vapor is present in the atmosphere, this is the first direct evidence of liquid water on the planet. These findings were published in the Proceedings of the National Academy of Sciences. The InSight mission concluded its scientific operations in December 2022, having recorded over 1,319 quakes. By measuring the speed of seismic waves, scientists could infer the materials these waves traversed. Professor Michael Manga from the University of California, Berkeley, who contributed to the research, noted, "These are the same techniques we use to prospect for water on Earth or search for oil and gas." The analysis revealed reservoirs of water at depths ranging from 6 to 12 miles in the Martian crust. Dr. Vashan Wright, lead researcher from UC San Diego's Scripps Institution of Oceanography, emphasized the significance of understanding the Martian water cycle for comprehending the planet's climate, surface, and interior evolution. He highlighted that water is a crucial factor in shaping a planet's evolution and addressed a fundamental question: where did all the Martian water go? Evidence of ancient rivers and lakes on Mars suggests that billions of years ago, the planet was much wetter. However, it has been a desert for approximately 3 billion years. Some water has escaped into space since Mars lost its atmosphere. Yet, as Professor Manga pointed out, much of our water is underground, and there's no reason for that not to be the case on Mars too. Researchers predict that similar reservoirs may exist across the planet. If this is true, there could be enough liquid water on Mars to create a layer more than half a mile deep across the surface. However, the location of this groundwater presents challenges for potential future colonization efforts. Professor Manga explained that this water is sequestered 10 to 20 kilometers deep in the crust, making it difficult to access. The discovery of liquid water on Mars not only enhances our understanding of the planet's geological history, but also raises the prospect of finding habitable environments. "Without liquid water, you don't have life," stated Professor Manga. So if there are habitable environments on Mars, they may now exist deep underground. In conclusion, the discoveries of liquid water flowing intermittently on the surface and the presence of reservoirs deep within the Martian crust mark significant advancements in our understanding of Mars. These findings illuminate the planet's potential to support life and the resources it may offer for future exploration. Isn't that incredible? Mars, once thought to be a barren wasteland, is now showing signs of life-sustaining elements. As we continue to explore this fascinating planet, who knows what other mysteries we'll uncover? Don't miss out on the latest updates. Like, comment, share, and subscribe to stay informed about the exciting world of space exploration. Together we can unlock the secrets of the cosmos.